Hi everyone, welcome to DevSecCon 2025. I'm really excited to be here. My name is Harshad Sadashiv Kadam, and I work as an infrastructure security engineer for Indeed.com. Today, I want to share a project with you all that combines three of my favorite things: zero trust, AI security, and deception engineering. The project is called MCP Threat Trap. It's basically a honeypot that lives on the edge. So let's get started. This talk is going to take you on a journey. We'll start with what deception engineering is, define the problem statement with the rise of MCP and attack flow. I'll then introduce the solution, walk through the architecture and flow, do a live demo, and then close with results and roadmap for where this goes next. Now, some of these concepts might be repetitive or very basic for some folks, so apologies in advance. Think of it as a refresher. Okay, before diving into AI, let's start with deception engineering. Traditionally, security is about prevention and detection, but deception flips this model. Instead of only defending, we deliberately create fake tools which are enticing for attackers. The point is simple: no legitimate user should ever touch them. So if they do, it's almost a high confidence signal. I like to think of it as a Tom and Jerry. Tom, our security engineer, is tired of chasing Jerry, so he lays down a trap: fake cheese. Jerry is the rogue AI agent or attacker. Jerry can't resist checking them out, and the moment he does, Tom knows exactly where he is. That's the philosophy behind deception engineering. And I wanted to test what happens if we apply this philosophy to AI agents, especially those using MCP. So, what's the problem we are trying to resolve over here? Enterprises today are wiring AI agents into their workflows. These agents can browse wikis, call APIs, and even reset passwords. And with the rise of protocols like MCP A2A, this becomes even more powerful because MCP gives these agents a standardized way to discover and invoke tools. That's great, right? Great for productivity. But with this, it also creates a new attack surface. As these attackers and AI agents can discover internal tools directly through MCP, defenders are buried in noise with no clear signal and blind spots which go undetected. Let me show you how attack flow actually plays out. MCP over here doesn't ask, should this tool be trusted? It simply lists a tool and the agent assumes they are safe. Now imagine a malicious extension, a rogue plugin, or even a compromised environment injects a fake tool into that list. The agent won't hesitate, it will happily call it. And here is the kicker: enterprise get no visibility into that call. No log of who invoked it, from where, or why. It's a complete blind spot. That's exactly the gap I wanted to explore. The solution I built is called MCP Threat Trap. The idea is simple. You deploy a fake MCP server at the edge, you populate it with fake internal tools, something sensitive like Okta admin reset, which can be very enticing for attackers. Then you wire that fake tool into a canary token that silently fires an alert when touched. Now, if an AI agent discovers and calls these tools, I know instantly. So instead of hoping to spot a bad behavior in the sea of logs, I flip the script. I use the agent's blind trust in MCP as the detection mechanism. Now let's walk through how this works. A Cloudflare worker runs as a remote MCP server. It exposes three tools: welcome tool, ask about me tool, and Okta admin password reset tool. So out of this, the first two tools are pretty harmless. They are like low risk tools, whereas the third tool is a decoy. When the third tool is called, it logs the metadata. The metadata includes the IP information, user agent, username, timestamp, and the tool name. And then it instantly fires a canary token that alerts me. From the agent's perspective, it's just another MCP tool, but under the hood, it's a pure deception. Now let me actually show you MCP Threat Trap in action. As you click on this link, it will take you to my remote MCP server. This is my worker's website, which is also running remote MCP server. There are two ways you can connect to my remote MCP server. One is through terminal using the curl, and the second option is through the AI playground, which is an MCP client. As you can see, I have three tools over here: welcome tool, ask about me tool, and the Okta admin password reset tool. So the first two tools are pretty basic. They are legit tools and They kind of give you the information about me based on my resume and GitHub links. And then the third tool, which is Okta admin password reset tool, it's a decoy tool. Now, what happens when you connect to my remote MCP server? So you can launch this AI playground, which is also acting as an MCP client. I'll take this URL for my worker node. I'll enter it over here and then I'll connect. Once I'm connected, I'll see the available tools over here, which is welcome tool, ask about me tool, and the Okta admin password reset tool. Now, let's see what happens when I call these tools. Can you tell me about Arshad's skills and projects? And I run it. Oh, looks like my trap is having a bad day. It's actually on purpose. I have realistic delays configured, so it behaves like a real system. So let me try again. Can you tell me about Arshad's projects? Okay. So as you can see, we got a response over here. Uh, some of my notable projects includes serverless honeypot, technologies used, my link for GitHub. So all this information is fed through my resume and GitHub repository. Now let's try to invoke this third tool, which is decoy. And you try to reset password for user Tom. You see, the password reset successfully initiated for Tom. It also gave me a recovery email, and it also has a reference ID, which looks very realistic for someone who is trying to attack. Now, behind the scenes, what happened was an alert was fired and my canary was triggered. If you come into my canary token, you will see all the useful information, which can be really great for initial investigation. It has the source IP, it has the date, it has the timestamp, it has the user agent, even the username. So this is something which security defenders can use for initial investigation. Now, let me actually show you how MCP Threat Trap works from terminal. So for testing it from the terminal, you can just copy paste this command, open your terminal, and then paste it over here. Once I've pasted it, I try to reset it now. See, I got a success message over here. Password reset successfully initiated. And now behind the scenes, a canary token was triggered and I got an alert. As you can see, the user agent over here is curl. So this is the information security engineers can use for the initial troubleshooting. Now that you've seen MCP Threat Trap in action, let's actually see how the Threat Trap was actually built. So this is basically my Cloudflare account. In this, if you navigate to compute workers, you will see the deception remote MCP server configured over here. Now this remote MCP server has pretty good metrics, logs, which you can basically use for correlating the alerts which you got with the canary tokens. So this metadata, which you have over here, can be used as the trail of logs to study the attacker behavior. Now, let's actually see what logic or the source code I use for configuring this worker. So if you come back to my honeypot and if you go to view source code, this will take you to my GitHub repository. Over the GitHub repository, apart from having the advanced canary token integration, I have some other features as well available over here, like rate limiting, sensitive username detection, realistic response delays, and error handling. And then my honeypot also supports MCP and SSC protocols. So how do you actually create this ThingSet Canary token? So if you come on the ThingSet Canary tokens, there are a range of tokens which are available. For the purpose of the MCP Threat Trap, I use the web bug token. You can easily create this token over here, entering your email ID and then like a reminder what this token is used for. Once you have this token, you come over here. This is you in the code. This is where you actually enter the token URL, and then this is the logic which I used for my tool, Okta password reset tool. So as you can see, I have introduced the network delay, some realistic honeypot behavior for the sensitive usernames and domains. And then you get like different messages for normal accounts versus sensitive accounts. Now that we have seen the demo, these are some sample results which I captured in the wild. A few patterns basically emerged when I was looking at this. You can actually see these alerts in my email as well. I've starred them, so you kind of know what I'm talking about. This project basically started as a POC to see if we can capture AI-based attacks. But within the first week itself, we got our first hit, and the POC turned into the proof of value. Over the course of months, I captured more such events. But one interesting result I captured was a scanning campaign hitting the honeypot from different locations. When I correlated those sources in the abuse IPTP, some of those were not reported before, thus giving me some early bird threat intel. So this confirmed my hypothesis. Deception works just as well for MCP connected agents as it does for human attackers. Now that we have seen the demo and results, why does this really matter? There are four main reasons. With this honeypot, we can extend our visibility into AI agent behaviors using MCP and A2A. This is a high signal, low noise honeypot. No one should ever touch this. So if someone does, we know it's a high fidelity signal. As it runs on the Cloudflare edge, there is no infrastructure overhead or patching. I like to call it security always on. And last but most important, this honeypot acts as a passive guardrail. It quietly monitors in background without blocking innovation. So what do we learn from this? Agents don't question trust. That makes them perfect bait for deception. So where does this go next? Kingset Canary token offers many such canaries which are free to use. We can customize deception and build many such enticing tools which MCP interact with these days. These alerts can be easily made actionable by feeding them into policy engine and integrated into zero trust. The GitHub repo is public. Anyone here can deploy this in minutes, extend it, and improve it. So my takeaway is simple. If MCP is going to be your way that agents access tools, let's make sure some of those tools are trap of our own design. That's MCP Threat Trap. And I would love to hear your questions or ideas for where deception engineering could go next. Thank you.